You already know his third law? What's his third law?
For every action, there is an equal and opposite reaction.
Yes. For every action, there's an equal and opposite reaction.
I have
Do you have an example for that?
If an elevator goes up, then there's another elevator going down.
Not always.
Not always.
All right. Okay, how about this? How about when you go swimming, you put your arms forward, and then you push them back. So you push your arms back, what does your body do?
Go forward.
It goes forward. Now, so that's opposite, right? I'm pushing back, get my body to go forward. So is that opposite?
Yeah.
Okay, what happens if I push my arms back really hard?
Go forward.
So the faster I push my arms back, the faster I'm going to go forward. What if I push my arms really slow? You're going to go slow. So it's opposite reactions, right? And then is my force equal as the force that I'm applying? If I apply a really hard force, is that going to force my body forward harder? So that's the equal part. Now Newton invented something called Newton's, I don't know what this is called? Cradle. Newton's cradle. So he invented this. This reinforces his law that we're talking about. So what I'm going to first do is I'm going to take one of these. We've got 5 marbles here. I'm going to take one of them, pull it back, and then let go and let it fall into the other ones. What do you think is going to be my reaction from my original action? What do you think?
It's going to push the other ball forward, and those balls are going to go back, and it's going to make that one ball forward.
So you're saying 4 are going to come out?
No.
Let me pull up my camera here. All right, so here we've got the 5 marbles. So she said that I'm going to pull this one back. It's going to come, and then all 4 of these are going to go out, and then come back and hit this one and go out. Is that what you're saying? All right. What else? Yes.
I think if you pull one back and let go, it's going to hit all 3 ones in the middle, and they're all going to hit each other, and then all 3 are going to hit the 5th one on the other end, and the one on the very end is the only one that's going to go back up.
Nice. I like your explanation. So it's going to move all of these 3, yet only this one's going to come out,
Yeah.
and then come back. Anything else? Yes.
Well, the ball will swing down because of gravity, and the kinetic energy from it will, because there's too much force on the other side, it will go from each marble, but it will travel. But the kinetic energy will travel and knock the next one out. Will knock the.
So you're still saying this one will come out?
Yeah.
But the force will travel through here and then knock this one out, and then come back, and then this one will come out.
And then eventually it will slow down because gravity is getting pulled.
Let's think about Newton's third law, though. He said for every what? Action, there is a what? Equal and opposite. So if I pull this one back and let go, what has to happen for it to be equal?
The other one has to come up and hit it back.
How many would have to come out over here? One would have to come out over here. And then come back. All right, so let's test this out and see how his law fits in. So I'm going to pull this one back and drop it. Is it equal?
Yeah.
And is it opposite?
Yeah.
It is happening on opposite sides, and it is equal on opposite sides. One on either side. All right. Now what if I pull 2 back? If I pull these 2 back and drop it, what's going to happen? Yes.
It's just going to be the same thing.
The same thing?
Just
So if I drop these 2, what's going to happen to these other ones?
they're going to go up.
Only 2
on the other end.
These 2 will come out?
Yep.
And then this one in the middle will just stay? It may move?
Yeah.
What else? So he's basically saying these 2 are going to hit, and then these 2 are going to come out, come back and hit, and then 2 again. Anything else? Yes.
Actually, I think the middle one will go back and forth a little bit when they're hitting the
the 4 balls in each side, it'll sort of go back a little bit, back and forth like that.
Yeah. So you'll be able to see it move a little bit because of
Yeah,
what?
but it won't like swing back and forth. Right?
Alright.
But like it'll.
So it'll still kind of stay in this area, but it'll bounce a little bit. All right, anything else? All right, let's give it a shot. Were we correct?
Yeah.
Is it opposite?
Yeah.
It's happening on opposite sides, and is it equal?
Yeah.
Yes. All right. Now, our tricky one. How many marbles do we have?
5.
What happens if I pull 3 of them back? What's going to happen? Yes.
The 2 will go like farther, and then they would come back, and the 3 would only go like out in the middle.
All right, so these 2 will come down. These 2 you said are going to go farther out because they have more force hitting them.
Yeah.
And then they'll come back, and then these 3 will go out again. All right, let's keep his law in mind. What else? What do you think? Yes.
I think that when you pull 3 back and then walk out, then the one in the middle will go with the other 2, and then go back and forth.
So the one in the middle will come over here. So how many total do you have coming out over here?
3.
3. So these 3 are going to come down. This one in the middle is going to have to transfer and go on here to have 3 on this side and come back. Anybody think anything different?
Well, it's kind of like what Kira said, or maybe exactly. When you pull 3 back, it'll go, and then it will push the other ones, but then the third one of the one you pulled will go on that, and then it'll get transferring back and forth between the 2 and making pull.
All right. So when it comes back, this one in the middle is again going to have to go back to this side. So this one in the middle is going to be swinging back and forth constantly.
Yeah.
All right. You got something else?
I think when you pull 3 back, when you drop it, it just applies more force, but the middle one stops, and it knocks this one, and then it just goes back to 2.
That's what I was So you're thinking that these 3 are going to come and hit, and these 2 are going to come out, right? Or are 3 going to come out? 2 are going to come out?
2 are.
And then those 2 are going to come back and hit, but in order to balance the force back out, only 2 of these are going to come?
Yes. And then it's going to
All right. Good thing. So that would still make his law true. Is that what you're?
Yeah.
Because since 2 came out, 2 would only come out on this side. But I started out with 3, right?
Yeah.
So do we have to have a way to make 3 come out on this side?
No.
According to his law?
Yes.
All right, let's see what happens. I'm going to pull the 3 back. Is it opposite?
Yes.
It is happening on opposite sides.
Yeah.
Is it equal?
Yes. Yes.
Yes.
Whoa. Wow.
All right. So in order to keep it equal and opposite, what had to happen? Yes.
Well, so when you pull back 3 and hit the 2, it sounds sort of weird when I say they knew what was going to happen, but they knew that they would have to, like, the 2 on the end would have to take the middle one to be able to hit the 2 on the other side just as hard.
So the middle one had to do what?
It had to be tossed back and forth.
It had to go along with these other 2 and then go back on this side. So in order to keep it equal and opposite, this middle one had to do double time. It had to go on both sides. So then what do you think is going to happen if I pull 4 of these back and drop them?
Same thing.
Well, same thing, but what's gonna happen? Yes.
3 will go to the other side. And then I'll keep doing that back and forth.
So I'll pull these 4 back, and you're saying these 3 middle ones are going to continue onto this side again?
Yeah.
So then how many would we have on this side?
4.
And how many did I start with?
4.
So is that equal?
Yeah.
And it's opposite?
Yeah.
Yes. Need something else?
I think that when 4 of them hit the one wall, the one wall will take this. It'll just do the same thing as the 3. So like, all 4 will hit the one, but then 4 will go back up and hit 1, and then 4 will go up with that one.
Yeah, so these
These
3 will go on with this one, and then it'll keep going back and forth.
Yeah, there's always going to be 4 in the air.
Alright, let's try it out. So I pull 4 of them back. So how many are on either side? 4 are on. So is it equal and opposite?
Yeah.
Yes. Alright. So when I have the balloon full of air and I let go of it, where's the air going to be pushed towards? This is the front end, this is my back end. What do you think? So the air is going to come out the back end, and the air is it pushing back this way or that way? So the air is pushing this way, but which way do you think the car is going to go?
That way.
So it's going to go that way. So the air is pushing towards the back, yet the car is going to move forward.
Yeah.
So if I blow my balloon up really big, what's going to happen?
It's going to go for longer.
It's going to go farther and maybe what else?
Longer.
And longer,
Faster.
faster. What if I only blow it up a little bit?
Then it'll go very slow.
Go slow
It's got very little range.
in very little range. But still, which way was the air blowing?
Back.
It was blowing backward, but the car was moving where? Forward.